Hello, and welcome to Retro Tech Repair. I have something very exciting to repair today and different to the other things that we've done on the channel. I've repaired many tabletop arcade games on this channel, but never a console. So today we have a console that is perhaps the ultimate tabletop arcade game. Yes, it's the GCE or Milton Bradley Vectrex. Let's get started. On the face of it at least, it seems to be in pretty nice condition. I didn't see any huge cracks in the enclosure. Obviously it's got some scuffs, some scrapes. It is rather old, but you know, the plastics seem to be largely intact. It has our control panel here, kind of separate control panel, which is quite nice. 4-button control panel. It's very dirty, of course, but the joystick feels springy, and the buttons, none of those are stuck. Just plugs into a 9-pin joystick port on the front there. Power controls, reset, power and volume, and really that's about it. So we'll just take a quick look at the eBay listing for this. Hopefully you can focus on that. It is Vectrex console, not working, including controller. I paid £72 plus £15 shipping. And the seller's description was this item was working, but now nothing at all. Happens when switched on. Sold for spares or repair. Item comes with the controller as shown. Joystick center's okay. Buttons seem okay, but cannot test. And the first thing that I'm going to do is I'm going to check the plug. There's a couple of reasons why I check the plug. Firstly, I want to see how the plug's being wired, and in this case, not particularly neatly. And then also I want to test this fuse to make sure this fuse is good before I do anything else. In this case, I'm going to go ahead and rewire this plug. The plug itself doesn't seem in terrible condition, but the wiring on it isn't very good. So we'll go ahead and test the fuse on this. Bring my meter in. It's a 13 amp fuse. I actually don't think this should have a 13 amp fuse. I think internally it's fused at about half an amp. Okay, so the fuse is good. So now I'll rewire this plug before I do anything else. So quick before and after here, I don't know if you can see that, but the plug here, there's a little nick in the insulation. It's really been wound in just to kind of get everything in before it hits this strain relief here. And same with the positive, that's really kind of twisted around and squished in here. So we're going to get those cut to a more appropriate length, get this tidied up and put an appropriately sized fuse in there. Now I've removed the strain relief, you can see just how much extra cable was being forced into that plug there. You've probably close to an inch of additional cable exposed beyond that which you actually need. Okay, so here's our new plug with new shorter leads. I said I think maybe it was a 5 amp fuse, but I'm thinking maybe it's a 3. So I'm hoping that by putting a 3 in we should be fine. Okay, so I still haven't plugged this in, and I'm not going to plug it in to show you because there are potentially lethal voltages inside of here even when it's unplugged, because of the voltages that are retained by the cathode ray tube. So I don't want to recharge that cathode ray tube. If I plug it in to try it and show you, then essentially, you know, if it does start to work, or if partly it's working, then I could recharge that CRT, and I don't want to do that. You should not do this at home. I am not an expert. This is not a how-to video. This is just how I do it video. There are potentially fatal voltages within this Vectrex. So a cathode ray tube will store electricity for an extended periods of time, electric charge, even after it's turned off. It's many, many times more than the voltage that comes from the mains. Potentially it could kill you if you're exposed to it, so you have to be extremely careful. If you do anything like this yourself, it's entirely at your own risk, and you must verify your own competence and your own safety before you do it. Anyway, all that said, let's take a look and see what's inside. So we're opening this for the first time together. So there it is. Just on the face of it, I don't see any horridly exploded capacitors, though I will take a look a little bit more closely in a few minutes. But before I do anything else, I'm going to discharge this cathode ray tube. I have a screwdriver here, flat-bladed screwdriver with a crocodile clip. That crocodile clip via a wire to the ground around the monitor. And with one hand behind my back, I'm now going to insert this underneath the cap of our Vectrex here.
Unfortunately, you can't really see this on the camera, but what I'm trying to show you on the video right now is me inserting the screwdriver under the anode cap of the cathode ray tube. The anode cap looks a bit like a big suction cup with a wire coming out of it that's stuck to the back of the CRT, but it's important that the metal of the screwdriver makes contact with the electrical connection which is concealed under the cap in order that the residual charge held within the CRT can discharge via the electrical connection through the screwdriver and through the lead that I connected to the ground around the CRT. All this was done with one hand behind my back, and now that I've explained that, let's return to the repair of our Vectrex. So I have a high degree of confidence now that I have connected the electrical contact of that through to the ground surrounding the monitor, and it should be discharged. I just removed the screw here, and underneath here is an internal fuse. And there's no indication on here what it should be, but there's a kind of sticker floating around inside, which I think came from there, and it says use a 250 milliamp slow blow type fuse, which surprised me actually because I thought it was a half amp, but apparently not. Anyway, I think that should belong on there. I'm just going to take a continuity measurement across that. Okay, so the fuse is good. Whatever the problem is, that's not it. Just out of interest, actually, I might just pop that out and see what value it is. Because everything that I had read online prior to this Vectrex arriving suggested that it would be a half amp fuse, but could of course be mistaken. And indeed it is 250 milliamps. Perhaps the 0.5 amp was for the US market. That would make some sense, huh? And in fact, yes, the board itself is labelled 125 volts, 500 milliamps, so presumably for the 240 volt systems like we have here in the UK, we have a different value. So what I'm going to do now is I'm going to take a look at the two boards in here. I'm going to take a look to see if I can see any bulging capacitors, any broken tracks, anything that's obviously burnt or anything like that. I might reset some of these connectors, just break them and remake them. Just that type of thing, just simple things to see if any of that is something that, you know, could be the problem for this Vectrex. And then once I've done that, I'll put it back together. We'll try it. We'll see if it's working. And if it's not, then we'll go in and do some more thorough diagnostic. But one thing I want to do is try and clean some of this dirt and dust off, because this is just filthy. Now I suppose you would have an anti-static brush ideally, but what I have is an old paintbrush. I did look at the caps on this board. I don't see anything that's obvious. They're bulging caps. Now, of course, that doesn't mean to say they're necessarily good, but I didn't see anything on there that suggested that they were not. They are old, and I haven't tested them, and I should probably recap them, but I think at this point I'm more interested in just trying to figure out what's wrong with the game and get it going. Okay, so we're back. I did spend quite a long time going over this board. I went over it with the magnifying glass, actually, from my helpy hands here. I didn't see anything much apart from one little solder joint right here that has a crack in it. Now that crack, I did check continuity, and the continuity is there, but I do wonder whether maybe when it gets warm or something like that, that might open up. And it is on a part that's on the heatsink, so obviously it does get warm. So I'm wondering whether when it gets warm that might open up, and that could be what caused this to be defective in the first place. Of course it could not be. What I'm going to do is, it looks like these have had some heat and maybe some rework. I'm going to clean up around here with some IPA, and then I'm going to remake these two solder joints and maybe a couple of the others around it also. Okay, so I didn't see anything else. So what I'm going to do now is I'm going to put it all back together and stand well back and turn it on and see what happens. So we're going to plug it in. I'm going to plug it in through a circuit breaker. GFCI, I think you'd call them in the US, or maybe an RCD in the UK. And I'm going to do it remotely. So I'm going to be a little bit of a distance away from it just in case something happens. But if it does, we will see it together for the first time. Ready? Well, nothing happened. Interestingly, there's not even a buzz or a hum or anything from it at all. You don't hear the static from the tube being charged or anything like that. Nothing at all. Which is not what I expected, I'll be honest. I expected it to make some kind of noise, but it really isn't doing anything. So I think we need to check to see if we have power going into it. So again, not really wanting to turn this on or open it up. What I'm going to do is take a resistance measurement. I'm just going to take the mains plug and I'm just going to see if we have anything across there? Nothing at all. So I took the back off, just discharged the CRT like I did last time, and now I'm going to take a look at the power coming in, the continuity into this transformer here. So we're going to take a look and see if this is primary is maybe open circuit.
So it occurred to me at this point in the filming that I was talking an awful lot about primaries and secondaries, and maybe that didn't make a lot of sense to people, so I thought I'd just take a second to explain what I was talking about. So what I'm talking about is a transformer, and a transformer is a way of transferring one voltage to another, and it looks something like this. This is some kind of representation of it. So incoming we have our 230 volts AC, and then there is a core, and then outcoming is some smaller voltage, but also in AC. So this would be something called a stepped down transformer. So what that means is that we have 230 volts, we have more coils on this side. On this side we have a smaller number of coils and hence a smaller voltage coming out. Now a transformer in our Vectrex is a little bit different to the simple one that I've just drawn, and you'd probably draw it diagrammatically something like this. So you have coming in one side with two coils, and then our core, and then coming out we have another side with two coils, but with a smaller number of turns on each coil. And what we have on this side, this would probably be across these two, would be our 240 or 230 volts AC, and then across one of these would be our 110 volts AC, and that would allow us to use the same transformer in different markets. On this side, out of the center, a center tap, we get 0 volts, and then on one side we have plus 9 volts, and on the other side we have 9 minus 9 volts. And then these would go off to be rectified to create a DC current for our Vectrex supply. So I think our Vectrex transformer is something like this. And when I talk about primary, what I'm talking about is this. This would be the primary, the input side, and this would be the secondary, which is the output.
So there's this little board in here which has the fuse on it. That looks to be good, and the connections on it look to be good. The positive comes in on this track, the negative comes in on this track and goes over a fuse, but then there are 3 connections to the primary. Hopefully you can see that meter okay. And the 2 windings, primary windings, come in here, and we'll measure the resistance across them. Looks to be infinite. So it looks to me like this transformer is open circuit, unless there's something in the wires between here and there. Looks like that transformer's gone open circuit. So I think we've concluded we can't do anything else today. I have this set to resistance measurement. I've got it across the primary on the transformer, and the transformer is open circuit. So we're going to have to get a new transformer. I don't think I can get a Vectrex transformer. I've googled this part number, I've not been able to find it. My hope is I can find something similar. My understanding from what I've read is that it's a 18 volt transformer with a center tap, so it's 9 volts either side of the center tap. So that's what I'm going to try and get. We can get that installed in the Vectrex, and we'll see if we bring it back to life. Hello and welcome back to Retro Tech Repair. Now a little less than a week has passed since we shot the last segment of video, and in that time a couple of things have happened. Firstly, this arrived. This is a replacement transformer. It's not custom for the Vectrex. It just bought it from a catalogue of electronic parts, so it's from an electronics supplier. I'm hoping it's the right type. I can't promise. I don't even know if it's going to fit, but we'll open up and we'll take a look. So this is a 0 9 volt, 0 secondary. I think they can be connected in series or in parallel or in center tap, and center tap is how we want it for the Vectrex. So what we're going to do now is we're just going to measure the resistance across the primary on this transformer. And if you remember on the last time when we tried it on the actual transformer from the Vectrex, we got an open circuit. So let's just try it now and see if we have some kind of connectivity across the primary here. There we are. So about 35 ohms across the primary. So I think this is going to work for us if I've got the right value of transformer and if we can fit it into the Vectrex case. So let's take a look and see if we can do that. So it's holding by 2 screws on a bracket. I think what I'm going to do is I'm just going to cut these wires off here, pretty close to the body of the transformer. The reason I'm doing it close is that I want to be able to use as much of the existing wiring as I can
The reason I'm not taking it all the way up to the transformer is if I do need to come in and reuse this for some reason, I want to have just enough left to solder on there. And we're going to do the same on the secondary side. Okay, so here's our Vectrex transformer, and here is our replacement. So there is some size difference, but it's maybe not too significant. Hole spacing is not the same, unfortunately, so we might have to mess around a little bit to get this to fit in here. After much thought and consideration, I have decided to mount our transformer here, where the old one was, but I've had to modify the plastics a little bit, just take a couple of nicks out of the bottom of the plastic here in order to get this transformer to slide in an appropriate position. So now, since the mounting holes are in a different place, I need to re-drill some holes to mount the transformer with the screw mounts. Okay, so since the outgoing transformer was a center tap on the secondary, what I need to do now is I need to link the two independent 0 volts on this transformer, because this is two independent coils on the secondary, in order that I have the equivalent of a center tap. So I'm just going to solder link wire between those two. So now our link wire is in. I'm going to go and solder some little extensions on so that when I mount it, I can accommodate the extra distance that's required for the cable loop. So we have our 0 volt wire center tapped and our two 9 volt supply wires here. And I'm just going to heat shrink those just for a little bit of extra security. So now we'll get this put back in the Vectrex, and then we'll solder up these two connectors for the AC supply. So here's our first AC line. And our second AC line. And then, as before, we're going to put some heat shrink tubing over there just to provide some protection. So now we can go ahead and remount our transformer, this time in the new mounting holes. So our transformer's now in, it's remounted in its new location with the new mounting holes. I popped a couple of cable ties on just to doubly secure it, and it's really very sturdy now. So the wires that I had soldered on to the 9 volt output from the transformer, I've temporarily twisted together onto the power supply cables to the Vectrex. I'm now going to solder those up, put some heat shrink over them, and at that point we should be ready to try this and see if our Vectrex is working again. So here comes the moment of truth. And nothing. Well, that's really disappointing. After all that, it still doesn't work. So we have our Vectrex powered up right now. Ground of my meter, or the negative of my meter, connected to the center tap on the transformer. And when I look at the output from the transformer, I see 9 volts on one of the lines, AC, and on the other output from the transformer, I see another 9 volts AC. But if I go to the switch, and the switch is on, I don't see any output from either side of that switch. So it's like the switch mechanism has failed. Now, because our Vectrex power switch is really hard to get to in there, I've just squirted it with a little electrical contact cleaner. And I'm going to work it for a couple of minutes back and forth, just in case I can free up some oxidization or something in there from lack of use. So having sprayed the switch with some electrical contact cleaner and worked it back and forth, I think now I have a working switch, which is quite a relief actually, because it would have been very involved to get in there and take that to pieces. So let me just check with my continuity check. If I probe between the two contacts with the switch closed, I have continuity on both sides. So now I'm going to reassemble our Vectrex again, and we'll try it one more time. Excellent. There is quite a lot of buzz, and I don't know whether that's typical on a Vectrex because I haven't owned one before, or whether it's because I have the unshielded transformer. but it does seem to be working fine. Okay, let's try a different game. I bought this on eBay also. Vectrex game. Let's see if it works. Starship.
And that just about wraps it up for our Vectrex today. It's an interesting design where the AC transformer is permanently connected to the AC supply and the switch is on the DC side of the circuit. It's my theory that the transformer failed and the game was put into storage not working. And then over time, through lack of use, the switch oxidized and it stopped working also. I doubt the reseating of the connector and the soldering that we did earlier in the video were actually required in order to get the game to work, but they may have increased its reliability over time and going forward. I'm sure there are more things that we could do to improve the performance of the Vectrex. Perhaps recapping of the supply and some further adjustments to ensure the display is better centered on the CRT. Reseating and perhaps even replacing IC303, which should improve the wiggle that you see on some of the videos and the misalignment that you see on some of the vectors that are drawn. All these are projects for another time, but right now we have a fully working Vectrex which I'm excited to play and enjoy. This was my first console repair, but I've already bought some more retro untested consoles on eBay ready for some future videos. I hope you've enjoyed the video today and that if you have, you'll consider hitting subscribe. In the meantime, thank you so much for watching Retro Tech Repair.
Hi, but what's inside here?
That could be a problem. Just the joystick works as it should.
Great.
And again. Oops. Select. I don't know if that's skill level or number of live around. I have it in a couple of places and then it stops. Grandstand scramble. Wonderful. Looking forward to fixing that.